Alright, this is the lesson on limits. So I'm looking at an example, and we stick with basic limits in this class and graphical examples and table examples. So you should have watched the book video lessons on the MyLab already. Those should be done first because they give you the basic understanding of the concept. And then I'm giving you additional examples here that you can look at. So again, make sure you've already watched the videos that are due for a grade that are in MyLab for section 1.1 and 1.2. All right, those should be done first. This is to supplement those to hit the topics that were harder one more time and to do more additional examples. All right, so this is a graphical example. So here I've got my function f of x graphed. All right, so this is the function f of x. All right, and so again, there's some stuff going on at -4, 1, and 6. And those are the ones we're going to be interested in, right? We always want to know. Limits are looking at the behavior of a function near a value. And so usually we're looking at stuff that's happening near something that's going on weird in my function. So either, there's an asymptotic behavior, hole in the function, jump, and that's what the cases are going to be here. There's going to be breaks in my function we're looking at. All right, so first, it's just asking you the function. So it's just asking you to find the function values at -4, +1, and +6. And so this is just asking you, when my function, when I plug -4 into my function, what's its value at -4? So the -4 is the x value, right? X equals -4. Well, what is the function value? Well, I go to my x equals -4. Change my color from red since the graph is red. All right, so this would be where the x value is -4, and I go up here and I look, and you'll notice that there's a hole in the function there. Right? There's a hole in my function at the point -4, 2. And so that means the function does not exist at -4, 2. There's a gap, jump. It's not in the domain. Right? Does not exist at that moment. And so the answer to that is we call it undefined. This is not in the domain of f of x. There's a hole at x equals -4. It doesn't exist. All right, so undefined at -4. All right, well, let's look at +1. All right, so +1, again, there's a jump here. Here's +1. This would be my x value 1 is at this moment. And this is where my function is jumping, right? There's a big gap there from one piece of the function to the next piece. But there is a point where it exists, right? X equals 1. What is my y value, my function value? Well, this time, if you look at this point, that is a closed point, right? The red dot's filled in. Whereas over here at 1, -2, it's an open point. And so it does not exist at 1, -2. That's just where the other piece starts. But it does exist at 1, 4. And so the answer to this is 4, right? The function value at 1, when I plug 1 into this function, 4 comes out. All right, so that one does exist and is equal to 4. And then 6. All right, so my x value is 6, so that's here. And so x value 6, there's a hole in the function here, but you'll notice at 6.2, so at 6.5 there's a gap. But at 6.2, it's sort of like they've taken this point and pulled it down here to 6.2. So they've taken the 6.5 point on the smooth curve and pulled it down here to the 6.2. That is also a closed point. That means it exists on my function. And so at x equals 6, we do have a y value. That y value is 2. Right? It exists there. When I plug 6 in, I get 2 out. All right, and so that's the function values. Now limits. All right, we're going to use limits. Again, we're going to stick to those 3 numbers because that's where interesting stuff is happening to my particular function. All right, so I have the graph down here to go with each one of them. All right, so the first limit we're looking at is the limit at 4. 4 from the left, 4 from the right. Sorry, -4. It's hard to see my negative there. -4 from the left, -4 from the right, and then -4 in general. Does it exist? So I'm looking here at my x value -4, right? That's where we're interested in. It did not exist. My original function did not exist at that x value. But limits don't care what's happening at the x value. Limits care what's happening near the x value as I approach the x value from the left and the right of it. And so the first one is we've got this negative up here. So remember, this means as x approaches -4 from the left, meaning from the values less than -4 on the left side, then f of x approaches what number? Well, I go up to my function here, and I'm on the left side, right? This is the left side. These are my x values that are less than -4. It's to the left. And then I go up to my function. So as I'm approaching from the left, I look on my function, and I stay to the left of -4, but I go up to my function. And so now I'm looking near my function values, and from the left, the function values approach, the function values are the y values, right? The y values approach +2, right? The y values approach that point, -4, 2. 2 is the y value. And so the function, so from the left, my function approaches 2. The y values approach 2. And so the answer to this is 2, right? As x approaches -4 from the left, the function approaches +2 from that side. All right, well, still looking at my -4, but now we're going to go to the right side. So as x approaches -4 now from the right, then how does the function behave if I'm looking on the right side of -4? And so I go up here, and maybe I'll change to a different color. Change to green. All right, so I'm on the right side now. So as I'm approaching, so again, remember, approaching means I'm getting closer and closer and closer and closer and closer and closer and closer to -4 from the right. Right would mean my values are bigger than -4, so it'd be -3.9, -3.99, and so on. And how is my function behaving when we do that? Well, then I go up to my function, and I look on the right side now. I'm on the right side. And on the right side, it's still approaching that same point, right? It's approaching that point -4, 2, and the y value is 2. And so the function is approaching 2. It's getting arbitrarily close to 2. It never actually gets to 2 because it doesn't exist at 2. But I can get to 2.001, 2.0000001, and so I can get as arbitrarily close to that as anybody could ask me to get. Now, again, I never get to 2, but 2 would be the wall, right? That's its limit, right? That's what the limit means. It's the wall. It's what it's approaching. It's approaching the wall, right? When you approach a wall, you can't actually go into the wall. You can just approach the wall and put your hands on it. Same idea here. We're approaching the wall 2. I can't actually be 2, but I can get as close to 2 as anybody could ask me to get. I can approach it and get as close to 2 as anybody can ask me to get. All right, so from the right, I'm approaching 2. And so this function equals 2 from the right. Since the left approached 2, the right approached 2, well, the general limit is equal to 2, right? Both sides approached 2. So on both sides, of x equals -4, the function approached 2. All right, and since both sides are the same, the function right, there's no plus or minus on this one. This is the general limit. The general limit exists and is true if both sides are approaching the same thing. All right, so if both sides are approached 2, it's equal to 2. All right, let's look at the next one. All right, so the next one we're looking at is 1. So the x value 1 is what we're focusing in on here. All right, so first, from the left of 1, right, that's what that negative means here. And so as x approaches 1 from the left, the arrow means approaches, then f of x, the y values, are approaching what? Well, I'm on the left side, so I go up here to the left side, and I go to my function. So if I'm on the left, the function's up here. And my function from the left, my y values are approaching this point. Well, the y values in that point are 4. All right, so my y values approach 4 from the left of 1, and so that limit equals 4. All right, well now to the right of 1. All right, that plus is the next one we're looking at. So as x approaches 1 from the right, then my y values, my function values approach what? Well, now I'm on the right side of 1, so my x values that are going in the function are over here. And so when I go to the function, I plug those x values in, those x values are going to give me these function values. So I'm down here now, and they approach this moment. All right, well, that moment that they're approaching, that point is an open point, so it never gets to that moment. But again, it approaches it and gets as arbitrarily close to it. Well, that moment is the function value -2, right? -2 is the y value it approaches. Right, that's the function value it's approaching. So from the right, it's approaching -2. And so the limit, as x approaches 1 from the right, my function approaches -2 on the right of 1. Well, on the left, it approached 4. On the right, it approached -2, which means they're approaching two different numbers. There's a jump there, right? On the left and the right, there's a jump. And so the general limit does not exist. The left and the right limits approached different numbers. And so we say DNE does not exist. And you do the same thing. You type DNE in on your homework assignment when a limit does not exist. All right, the last one for this particular example. All right, so 6 is the next one we're looking at, x equals 6. Remember, 6 existed at that point, so the function value was 2. But the limit's going to be different. All right, so first from the left. So as x approaches 6 from the left, what are the y values? What's the function doing? All right, so I'm to the left of -6. Left means I'm on this side. And so I got up to my function, and it's the function, it's the red line. What is the red line approaching? Well, it's approaching this 0.65. So the function value is the y value, and so it's approaching the y value 5. And so 5 is the limit from the left. Now we look on the right. And as this case turns out, it's going to approach the same thing. As x approaches 6 from the right, the y values also approach 5. If I go look at my picture, so this limit's going to be 5. Right, if I'm on the right, I'm on this side of 6. So that's this piece of the function. And it is. On that side, it's still approaching. So I go up to my function, which is the red line, and it's still approaching that open point 6.5. So from the right, it never gets to 5. It doesn't ever equal 5, right? The function value equaled 2. But 5 is the limit from the left and the right, right? And so that general limit does exist and is equal to 5 because both sides approached 5. All right, they're equal. Left approached 5, right approached 5. And so both are equal. All right, so that's the first example. So I'm going to stop the video there, and then I'm going to do example 2 in the next video, which is, again, it's just another example of a graphical limits. All right, and we'll look at it, and they're going to be the general cases. All right, so we'll stop here. We'll pick it up in the next video. Pick up the guided notes.